Georgia Standard 3 NF2 states, understand a fraction as a number on the number line. Represent fractions on a number line diagram. Part A. Represent a fraction 1 over b on a number line diagram by defining the interval from 0 to 1 as the whole and partitioning it into b equal parts. Recognize that each part has size 1 over b. Recognize that a unit fraction 1 over b is located 1 over b whole unit from 0 on the number line. Part B. Represent a non-unit fraction a over b on a number line diagram by marking off a lengths of 1 over b, unit fractions, from 0. Recognize that the resulting interval has size a over b and that its an endpoint locates the non-unit fraction a over b on the number line. In first and second grade, students discuss partitioning in equal shares. Students will have partitioned circles and rectangles into 2, 3, and 4 equal shares. Transitioning to third grade is the first time students are understanding representing fractions through the use of a number line and the developing understanding of fractional parts, sizes, and relationships between fractions. This is a foundational building block of fractions, which will be extended in future grades. Students should have ample experiences using the words halves, thirds, fourths, and quarters, and the phrases half of, third of, fourth of, and quarter of. Students should also work with the idea of the whole, which is composed of 2 halves, 4 fourths, or 4 quarters. This is a different perspective than the typical instruction at this level that is solely focused on fractions as part of a whole. This standard looks at fractions as a rational number as a subset of the set of real numbers. It allows students to see the relationship of numbers and also connects the concepts of measurement to an integral component of fractions. The number line is in essence a ruler. The distance or interval between 0 and 1 is the whole, which is the same as the rectangle, showing the whole. Let's take a deeper look at Part A of 3 NF2, which emphasizes the importance of the unit fraction. The number line diagram is the first time students work with a number line for numbers that are between whole numbers, that is between 0 and 1. In the number line diagram, the space between 0 and 1 is divided or partitioned into 4 equal regions. The distance from 0 to the first segment is one of the 4 segments from 0 to 1, or the unit fraction 1/4. In Part B of NF2, the distance from 0 to the 4th segment is 4 segments that are each 1/6 long. Therefore, the distance of 4 segments from 0 is the location or position of the non-unit fraction 4/6. Creating unit fractions on a number line is actually more challenging than it sounds. The students will be developing their conceptual understanding of how halves should be drawn larger than thirds and so forth. If you were to ask your students to define the numerator and denominator, what do you think they would say? Perhaps the number on top or the number on bottom? It is very important that we model accurate fraction vocabulary that embeds meaning, not just mnemonics. Van der Waal gives us a great example of how to do this when he states, the numerator counts, the denominator tells what is being counted. Fraction symbols are just shorthand for saying how many and what is being counted. Now let's look at some common student misconceptions when using number lines. In this task, 2 tick marks were intentionally left off, not to trick the students, but to assess their understanding the role that equal parts play in naming fractions. This is okay and even recommended that teachers do something similar once students have been introduced to fractions on number lines so that students are challenged to think about the spacing between whole numbers. The fraction for this point would actually be 8/10, reminding students that when we multiply and divide, we need equal groups, just as we do with fractions, because fractions are a representation of division. It's very important we make this connection between multiplication and division with fractions with our students. In this misconception, the student did not start with a fractional representation of 0. Once again, there's not correct spacing of the fractional intervals. This number line also shows the location of 8/10. This is a very common measurement error. The student mistakenly counts 0 as the first length unit. It would be important to relate back to measuring with a ruler, which students did in second grade. It is critical that we do not limit our students to working with number lines that contain endpoints of 0 and 1, as you will see later in this video. In this misconception, a student does not understand that with every whole number, a new whole is created with the same number of equal parts as the original whole. So the location of this fraction is 8/10 because the whole is 10/10. The following videos and slides were created throughout the administration of the Unit 5 Frameworks tasks. I like to move it, and using fraction strips to explore the number line. Extensive practice folding, manipulating, and discussing the fractional unit sizes from various strips of paper and fraction bars were done during lessons to enable students to gain a deep understanding of the size of each fraction. Students then created number lines and located points on those number lines. Later, they located equivalent fractions using their fraction strips. First, then transferred the knowledge by finding equivalent fractions on the number line. Listen as I question this student about how she makes sense of showing one whole on a number line and how to segment it into equal units.
Okay, can you draw a number line that has one whole on it? Okay, excellent. Can you partition it into thirds? Why did you choose to do it like that?
Because if you draw it into thirds, you would draw 2 lines. But if you put 3 lines, you would have 4. So I would draw 2 lines, and that would partition it into thirds.
Okay, can you label each fraction?
0 thirds, 1 third, 2 thirds, 3 thirds.
What fraction is equivalent to one whole on your number line?
3 thirds.
In these next 2 videos, listen for how the student creates her number line and makes sense of why she is placing the fractions where they belong. Also observe how the student explains why a certain fraction is placed at its location on the number line.
Okay, draw a number line that has 2 holes on it.
I drew a number line from 0 to 2, and then I put my 1 hole, so it's 2 holes.
Excellent. Can you partition that into sixths? Excellent. Can you tell me what you did?
I partitioned each 2 holes into 6, and then
How did you do that? I heard how you were counting. How were you counting?
I counted like 1 6, 2 6, 3 6, 4 6, 5 6, 6 6,
6 6. Yes.
and 7 6, 8 6, 9 6, 10 6, 11 6, 12 6.
Okay. Can you go ahead and write the fractions for each one? Why did you box those certain fractions?
Because each one is equal to a whole, so you would need a box them because they're equal to a whole.
Okay, good. Can you plot the location of 8 sixths?
8 6.
Excellent.
In the next few student videos, listen how the students use their knowledge of half as a benchmark in fractions, as well as their understanding of what a unit fraction is and the size of that unit fraction to place their point for the fraction I gave. Partner talk is crucial to show deep understanding of fractions. If a student can explain their mathematical reasoning to someone else, mastery will be achieved and misconceptions can be fixed. Notice how the students build on each other's thinking during their partner talk to plot their point, and then use the fraction tiles to check their estimation.
Now you're going to work with a partner, and I want you to plot 3 halves. Where would 3 halves go? Talk to each other about it and make sure.
So probably right there. Yeah, that's what 0 has 1. So by half this 3.
That's pretty good. You guys got pretty close. Okay. How'd you guys do? Good job.
In this interactive website game at visualfractions.com, Grampy's favorite game is hide and seek. He is hiding at a fractional distance between the beginning and the end of the hedge. The picture tells the number of parts the hedge is divided into. Grampy is hiding behind one of those parts. The students are to guess which part he is hiding behind. Grammy will help the student by pointing to their right if the fraction is too small and to their left if the fraction is too large. Students see the top of his head behind the hedge. The computer will keep track of the number of times the student finds Grampy and the number of tries. This is a great exercise for determining the relative distances of different fractions along a number line, how the numerator determines the size of a fraction, and how the denominator determines the size of a fraction. This last website, Battleship Number Line, students have to move the battleship to the correct location so the torpedo will hit it. If it sinks the battleship, the student gets a point. Once again, this is a wonderful exercise for students to practice estimating the location of a fraction.